So when you hold this rock is 4.5 billion years old. It's 500 million years older than any rock on Earth. And so if you really want to understand the origin of our planet, of our solar system, you go to rocks like these.
Hey smart people, Joe here. I'm holding a chunk of an asteroid that fell to Earth. It's a pretty amazing thing to hold in your hands. I think everyone can agree space rocks are awesome, but these little specks of dust might be the coolest space rocks of all because they hold answers to some huge questions. How our solar system formed, how Earth got the first ingredients for life, maybe even where to find the resources that'll one day let humans travel beyond Earth. These are tiny pieces of an ancient asteroid collected and brought back to Earth in one of the most ambitious missions NASA's ever attempted. And I was invited to be one of the first people to see those rocks up close. Today, you and I are gonna learn how these specks of space rock will help unlock our solar system's most ancient secrets.
My name's Tim McCoy. I'm a curator of meteorites here at the Smithsonian's National Museum of Natural History.
Most of the time, Tim studies rocks that have fallen from the sky, like the one I'm holding.
The amazing thing about this rock is what it's made of. This is a sedimentary rock, but it's a cosmic sediment. So each of these little particles in here was a free-floating thing in the cloud of gas and dust our solar system formed.
On Earth, sedimentary rocks form after eons of erosion, piling up little grains of dirt and sand and squishing them together. But a space rock like this is formed by tiny rocks and dust and gas getting pulled together by gravity.
And these little white things, these are the solar system's dust bunnies. So these were little blobs of dust floating around in the early solar system before anything else formed. And so just like the dust bunnies in your house, this is the dust bunnies of the solar system.
It is wild to me that gravity can do enough work to even bring this stuff together. But 4.5 billion years is a long time.
This is the process that has formed every object in our solar system, planets and moons and asteroids. Some of those bodies are solid, but some of them are more like piles of rubble, these tiny bits barely pulled together by gravity. Yet, they're still able to create asteroids up to hundreds of kilometers across.
And so you're just adding and adding and adding, and eventually you end up making an asteroid. And so if you go to a certain kind of asteroid, you're gonna find a rock just like this sitting on the surface of that asteroid.
Now, asteroids and rocky planets, including Earth, they all formed at about the same time, around 4.5 billion years ago. But Earth doesn't actually have any rocks that old. The oldest rocks on Earth aren't actually from Earth, they're from space. Let me explain. Here on Earth, wind, rain, and chemical reactions wear down and change old rocks. And meanwhile, there's whole swaths of Earth's crust that get recycled through plate tectonics and volcanoes. Over time, these processes have wiped away Earth's earliest rocks. Those traces of our planet's earliest history are just gone. Our oldest rocks are nowhere near as old as our planet. But asteroids don't have plate tectonics or weather cycles. They can't hold on to an atmosphere, so they don't have things like wind wearing them down. So unlike planets, asteroids basically haven't changed in all those years since they formed. For the most part, they're just cold rocks sailing through space, snapshots of the solar system as it was billions of years ago. That chunk of rock I'm holding came from an asteroid. It formed in the early solar system, broke off, blazed through our atmosphere, and crashed onto our planet. Scientists like Tim are interested in rocks like these because they're full of secrets about an era before Earth even existed. They let us explore the chemistry of the early solar system and how it evolved. But there's one big problem. Space rocks that land on Earth are contaminated by Earth. All of our weird chemistry, all the life. To get the best, most accurate picture of the early solar system, we need to go get some very, very old rocks that have never touched Earth's air, our dirt, our water, and well, NASA just did that. They sent a spacecraft to an asteroid to pick up some rocks and bring them back to Earth. They'll be studied, completely sealed off from earthly contamination. A pristine time capsule of the early solar system. So what will we find in that time capsule? Maybe clues about how life started. Now, obviously the ingredients for life must have been around before life arose, but where did they come from?
In here, for example, in many of these rocks, you find carbon and nitrogen, and in some of them, you find hydrogen and oxygen, water in there, as well as phosphorus and sulfur. So these are the things that make up you and me and narwhals and sycamores and leeches and T-Rex and everything that ever has or does now live on this planet comes from rocks like these.
The ingredients for life, they actually aren't especially fancy, chemically speaking. Amino acids, or the building blocks of DNA, these could have formed out of simpler chemicals that were already in the solar system before life arose. And scientists like Tim have actually found some of these chemical building blocks in meteorites. But here's where that problem about Earth contamination comes in. When studying a rock that fell to Earth, scientists can never be 100% sure that the chemicals they find didn't come from Earth.
In the case of some of these rocks, like we know that they have organic molecules and things that were before life here on the planet. But every time one falls on Earth, it's contaminated by life. Life is everywhere on this planet.
Too much life. As a biologist, it's a little offensive, but I see what you mean.
Yeah, I mean, I like to describe Earth as a perfectly good planet with an annoying biological scum covering it.
Scientists have been worried about space contamination going back to the moon missions. When Apollo astronauts came back to Earth after visiting the moon, they spent 21 days in an airtight quarantine chamber, just in case they'd brought back some unknown lunar life back to Earth. It could infect the planet and kill us all. But what Tim and other scientists are worried about is life from Earth contaminating the space rocks they want to study. So they had an idea.
Let's go get one, bring it back in a way that it's not contaminated, and really be able to understand water and organics and the things that are out there in space that as soon as a meteorite falls on Earth, within days, it's contaminated. So let's get it pristine. Let's bring it back ourselves.
Now, hopping over to an asteroid to scoop up some rocks and shoot them billions of miles back to Earth, that's no small task. People have only pulled it off twice before. In 2010 and 2020, Japanese probes brought back tiny samples from 2 asteroids. But NASA wanted to go to an even older asteroid and bring back even more material. They chose one called Bennu. Bennu is a near-Earth asteroid. It mostly orbits between Earth and Mars, but it crosses over Earth's orbit when it comes closest to the sun. Bennu actually has a super slim chance of hitting the Earth in the 22nd or 23rd century, but for now, it's nothing to worry about. It's still tens of millions of miles away. In 2016, NASA launched a probe to this rock, a mission called OSIRIS-REx.
So O is for origins, and that's the big one for us, is how did these rocks come to be? How did this asteroid come to be? How did the solar system come to be? And so we're rock historians. We're looking at the history of this rock to understand the history of our solar system. The next part is spectral interpretation. We're looking at the light that bounces off asteroids to try to understand what most of the asteroids are like. Resource identification, right? We're going to identify the resources on this Earth. And then security, right? We know that these things occasionally strike Earth. The damage they do is dependent on what they're made of. So it kind of goes back to the spectral interpretation. We want to know what they're made of, how they move. And the last part, the Rex, is regolith explorer. Regolith is the fine dust on the surface. We want to go way down and look at tiny little pieces. So we go all the way from astronomical observations down to atomic scale observations within this one mission on this one asteroid to help us understand the history of our whole solar system.
It took 2 years just to get to Bennu. But in 2018, OSIRIS-REx finally entered orbit around it. But how do you land on a big pile of rubble that's less than a kilometer across? It's barely being stuck together by gravity. NASA came up with a pretty cool idea. They spent 2 years just circling the rock, mapping its surface, looking for the best, safest spot to land. And finally, they picked their target. They maneuvered the spacecraft lower and lower, adjusting its speed to match the rotation of the asteroid. Then, when they were right over the surface, they punched it in the face. Landing on Bennu wasn't like landing on Earth or the moon. NASA described it more like punching a ball pit. That loose ground just gave way under the probe. OSIRIS-REx spent a grand total of 5 seconds on the surface of Bennu, but it made the most of it.
And we used this really clever device that released gas that fluidized the loose particles, what we call the regolith, caught them in this little container, brought the container up, put it in a capsule, essentially cut the arm off that held it, closed it all up, and then take back off. We spent another several months before we decided we were ready to leave the asteroid, and then 3 years to get back to Earth.
And in late 2023, 7 years after it launched, that capsule carrying a few hundred grams of asteroid crumbs re-entered Earth's atmosphere.
Came in over the west coast of the United States, and a few hours later it was on a parachute and then landing in Utah. A day after that it went to Houston, and now we have samples to study.
Well, just looking at it, the sample might not seem very special, just some dark rubble. But geologists have a special machine for looking at samples like these, and it shows us things that our eyes could never see.
So I love cool science machines, and that looks like a really cool science machine.
It's a super cool science machine. We bought it just to study these rocks. And so up there, it generates a beam of electrons that come down and hit a sample that's down in here, and that generates X-rays. And these devices on each side actually measure the energy of those X-rays and tell us what elements are in there. So
that gives you a fingerprint of
it gives us a
element you're
chemical fingerprint, yeah, of not just the element, but by knowing what set of elements in there and looking at the shapes of the minerals, we can tell you what mineral it is. So if you take this hexagon-shaped grain like this, you can see we put a point there and we hit it and we get iron and sulfur in here. So we know this is a sulfide. This is a mineral that was deposited by water 4.5 billion years ago, when this asteroid was essentially a wet mud on the surface of an asteroid.
This is the kind of analysis scientists are doing on the Bennu sample. There's an actual sample of the Bennu asteroid in that machine, and they've already made some really cool discoveries about those space rocks. Like, they've found water tied up in the minerals, which supports the theory that billions of years ago, Earth's oceans were filled with water by the countless asteroids slamming into the young planet. And in the future, water from asteroids could also be a big deal for space travel. You're gonna get thirsty on your way to Mars.
Now you might think, people talk about space mining, we're gonna go and we're gonna get rare metals, we're gonna do all this sort of stuff, but the most valuable resource in space is water. It costs a lot of money to launch water into space. If we can get it in space, if we wanna put astronauts on the moon to live, if we wanna go to Mars, we need to get water in space. Instead of paying all those launch costs, we mine it in space.
There's a bunch of other stuff in these rocks too. You might have noticed they're super dark, mainly because they're full of carbon and organic molecules. This is exactly what geologists were looking for, because these could hold some big clues as to what sort of molecules eventually led to the emergence of life here on Earth.
And throughout this rock, it has carbon and nitrogen, phosphorus, sulfur, all the elements that make up us. I mean, this is the stuff that everything you know came from. And it's not just you and me and the narwhals. You know, all the gold that you've ever known is in a rock like this. All of the aluminum you've ever known is from a rock like this. Basically 4.5 billion years of the Earth processing it and then us processing the Earth have produced everything you know from the elements in a rock like this.
There have also been some surprises. In all that dark debris, there's these little light flecks made of minerals that scientists haven't found in other space rocks that they've studied. And so far, it's a mystery as to what those are even doing there. So geologists already have plenty to work with, and they will be making discoveries from the Bennu samples for a long time.
Think about it, these are so fine grained. I mean, these are micron sized grains. So if you have a millimeter sized piece, if you have a piece that's this big, there's literally tens of thousands of grains in there that we can analyze to study. And so, you know, these infinitesimally small pieces are yielding this enormous knowledge about where we come from and how our solar system formed.
Scientists will be studying these tiny pieces of rock for generations, maybe. This is like real time travel in a way. Scientists have this piece of our solar system frozen in time, and locked in those grains of dust and rock are answers about how our planet and all the others came to be how they are today. You know, every great scientific story ends with another question, and I think this leaves us with an amazing one. Maybe in another solar system, made of the same elements and molecules, full of the same rocks and minerals as ours, could a planet like ours happen there too? I hope we find the answer. Stay curious. Hey everybody, thank you so much for watching this video and for sticking around to the end. And here's a fun fact for you. NASA asked people for ideas about what to name that asteroid, and Bennu was picked by a kid. I think that's really fun, and I want to know what you would name an asteroid if you got the chance. leave me a comment down below and let me know. As always, thank you to everyone who supports the show on Patreon. We literally couldn't do it without you. What a cool thing to see. You help make that possible. If you would like to join our group of esteemed patrons, the people who help make this show possible, there's a link down in the description. We have a lot of fun over there. You get to see videos before anyone else and a bunch of other cool stuff. It's right down there. Have a click, and we'll see you in the next video.
Imagine you're a farmer out plowing your field, and you find that, and you'd be like,
you're gonna break your plow.
Yeah. Oh yeah.